For this question, we want to find f plus g, f minus g, f times g, and f divided by g. We also want to determine the domain for each function. So since we want to find the domain for these combined functions, I want to find the domain of these individual functions first. The function f of x equals square root of x is a radical function, or sometimes called root function. And this is a square root, which means it's an even root. So with even roots, we want to have what's underneath the radical to be positive or 0. So we're going to take the expression that's underneath the radical, which for this example is just x, and we want to set that greater than or equal to 0. If we represent that on the number line, that would be a filled in dot at 0 and shading all the numbers greater than 0. So we get a domain of f to be everything greater than or equal to 0, which in interval notation is 0 to infinity with a bracket on the 0. Then when we look at the other function, g of x, that is a polynomial function, more specifically a linear function. So it's polynomial or linear. And we know that the domain of polynomial functions is all real numbers. So we're going to say that the domain of g in interval notation is negative infinity to infinity. So those are the domains of the individual functions. We'll use that later when we're finding the domain of these combined functions. Let's find the domain of, so let's find f plus g and then the domain of f plus g. So f plus g of x is going to be found by taking the individual function f and the individual function g and adding them together. We want to do f of x plus g of x. And f of x is the square root of x, and g of x is x minus 8. So I've added those functions together to create that new function f plus g. There's not really any simplification I can do with this since none of these are like terms. And so I'll leave my function f plus g of x to be square root of x plus x minus 8. Now when we combine a function together, we have to consider the individual domains to create the domain of the new function. So on this portion, we need to follow the rule that the domain has to be greater than or equal to 0. And on this portion, we need to follow the rule that says it can be any value. When we put them together, we're going to take the most restrictive one, which is this one here, where x needs to be greater than or equal to 0. And that will be the domain of f plus g. So it'll be 0 to infinity. Then I'll find f minus g of x. So I want to take f of x and subtract g of x. F of x is square root of x. I'm going to subtract g of x. I want to make sure I subtract all of g of x. So I'm putting parentheses around the x minus 8. And I'll use the distributive property to distribute that negative. And that would give me negative x plus 8. So my function f minus g of x is square root of x minus x plus 8. So the domain of this, just like in the conversation about addition, needs to be the most restrictive of the two, which is that x needs to be greater than or equal to 0. The domain of f minus g is 0 to infinity. So now we'll find f times g of x. That's f of x times g of x. F of x is square root x, and g of x is x minus 8. I put parentheses around the x minus 8 to make sure that we multiply the whole functions together. We can leave our expression in this factored form, or if you would like, you could also use the distributive property, and with the distributive property we would get x square root of x minus 8 square root of x. And when we're looking for the domain, we're going to choose the most restricted of the two, which is that x needs to be greater than or equal to 0. Finally, we want to find f divided by g. That would be f of x divided by g of x. F of x is the square root of x, and g of x is x minus 8. And there's not any simplification we're going to do there. We're going to leave it as the square root of x over x minus 8. And once again, you have to consider the individual domains. And we're going to choose the most restrictive, which is 0 to infinity. However, because we've introduced division, we have another restriction that has come up, in that the denominator cannot equal 0. So 8 is another restricted value. So if we think about this on the number line, we've restricted from 0 to infinity. But now we have a new restriction of 8, so 8 is here, and 8 needs to be excluded. So we're going to take that point away, and we want to represent this interval and this interval. So that would be from 0 to 8, union with 8 to infinity, and that will be the domain of f over g. For this question, we want to sketch the graph of this function and identify all the properties that will apply. Our function is f of x equals 1 over x, and I'm going to graph this by plotting points. My standard set of points include -2, -1. I usually choose 0, but 0 is an undefined value for this function. So instead of choosing 0, I'll choose a couple points that are close to 0. On one side, that would be -1/2, and the other side, +1/2. And then I'll continue with my standard points, which is 1 and 2. Now this function is given a name of reciprocal function because every number that you substitute in, you get out the reciprocal of that value. And you'll see that if I substitute -2 in, 1 over -2, that's -1/2, and -1/2 is the reciprocal of -2. I'll continue on with 1 over -1, and that's -1. -1 is the reciprocal of itself. 1 over -1/2. If I take my time simplifying this, I would write this as 1 divided by -1/2. And when we divide fractions, we multiply by the reciprocal, so that's 1 times -2 over 1. So we get -2. And -2 is the reciprocal of -1/2. You can do the same thing with 1/2. 1 over 1/2 is the same thing as 1 divided by 1/2. With fractions, we multiply by the reciprocal, and that's 1 times 2 over 1. and that's 2. So 2 is the reciprocal of 1/2. We have 1 over 1, which is 1, and 1 over 2. 1/2 is the reciprocal of 2. So I have a list of ordered pairs, which I'll plot on my picture. I have -2 and -1/2, -1, 1, -1/2 and -2, 1/2 and 2, 1, 1, and 2 and 1/2. I can connect these points. I'm going to connect this with keeping in mind that 0 is an undefined value, and that means I'm going to have a break in my line at that place. So I connect these 3 points together, connect these 3 points together, demonstrating a break at x equals 0. Some special features of this function is it has a vertical asymptote and a horizontal asymptote. They both occur at 0, and what that means is that our graph is getting closer and closer to x equals 0. The y approaches infinity and negative infinity, and then here my graph is approaching a y value of 0, getting closer and closer without ever reaching it. So this is the graph of the rational function, and I want to take a look at these properties that I have listed below. The first property is the function is an odd function. So an odd function has origin symmetry, and origin symmetry is when you have a mirror image over the origin over 0, 0. You're looking for a mirror image in opposite quadrants. So if we look at quadrant 1 as well as quadrant 3, we can see we have a mirror over that origin. If we look in quadrant 2 as well as quadrant 4, you can see that they're both empty, creating a mirror image in those quadrants. So we would select that this function is an odd function. The next question, or the next property, says the range of our function is -infinity to infinity. And as I look at this, I'm going to hold my ruler horizontally going from bottom to top, and my range starts at -infinity and continues on, but because of the horizontal asymptote that we discussed earlier, there's a break in the range at 0. So we never achieve a y value of 0, and so the actual range is -infinity to 0, union with 0 to infinity, and so we would not select this property for this function. The next statement, the next property, says the function is a linear function. And for the function to be linear, we need the function to be in the form f of x equals mx plus b. So because our variable in this function is in the denominator, that makes it a rational function instead of a linear function. And so we would not select that property. The next property says the function f is an even function. For a function to be even, the graph needs to have y-axis symmetry. And y-axis symmetry is when you have a mirror image over the y-axis. So anything on the right of the graph needs to have a mirror image on the left. And you can see that quadrant 1 and quadrant 2 do not mirror each other, so we would not select the property that this is an even function. The next property says the function is increasing on the interval from negative infinity to infinity. As I trace this graph going from left to right, I can see that my y values are decreasing. And if I continue, my y values are still decreasing. So the function is not increasing over the interval negative infinity to infinity, so I would not select this property. The next property says the domain is from negative infinity to infinity. I'm going to hold my ruler vertically and notice that our domain would start at negative infinity and continue until we get to this vertical asymptote of 0. 0 is not included in the domain, and so the domain is not negative infinity to infinity. The actual domain is negative infinity to 0, union with 0 to infinity. So we would not select this property. And finally, none of the above properties apply. That statement is not true since I have selected a property above, so we would not select this property either. So the only property we would select is that the function is an odd function. Thank you for checking out my videos. Have a great day.